Good morning to all. I am Subhashini, Department of Civil Engineering, Government College of Engineering and Technology, Tirunelveli. In this presentation, we are going to see about the subject prefabricated structures. Unit 1, Design Principles. In this presentation, we are going to see about the basic topics like definition, need for prefabrication, advantages, disadvantages, limitation, uses, principles, methods, classification, modular coordination, standardization, transporting, and erection. What is prefabrication? From the name itself, we can see pre means before, fabrication means making. So making the structural components in the factory and then transporting the components to the construction site. That's why it is called as a prefabrication. These are the civil engineering requirements, which are economy in cost, to improve the quality, to speed up the construction, to use the locally available materials, to use the material which possesses their characteristics like lightweight, easy availability, thermal insulation, and non-combustible. Shorter construction time, easy of expansion, utilization of material, attractive finishes. These are the main requirements of prefabricated structures. The advantages are self-supporting ready-made components can be used, construction time much more reduced, quality control maintained, time exposed in bad weather conditions, less wastage, and on-site congestion can be reduced. Disadvantages: we need a very skilled labor on the manufacturing site and at the construction site. Careful handling of concrete components is required. Leakage at the joint should be prevented. Heavy duty cranes and precision measurement to be in position. Very costly when the factory is very far away from the site. Limitation of prefabrication. It's very costly, uneconomical for smaller project, transportation difficulties, safety of crane and other support system, difficulties in transportation of very large components, waterproofing joints. These are the main uses of introducing the prefabrication system. The first one is time consumption, and the second one is the work does not affected by any weathering condition, and the greater quality is maintained throughout the construction, and also the higher conformity in building code standards. There are less wastage of materials in the site, and also the less theft of materials. Materials are protected from the exposure to the weathering conditions. Worker safety and comfort level is higher importance than the site-built construction. Computerization of production process permits the higher degree of customization at the affordable cost. Quality control and the factory sealing and design can be ensure high energy efficiency. There are two methods of prefabrication. One is plant prefabrication, another one is site prefabrication. The images shows the plant prefabrication and also the site prefabrication. Classification of prefabrication. There are several types of prefabrication: small prefabrication, medium prefabrication, large prefabrication, partial prefabrication, open system, closed system, total prefabrication, cast inside prefabrication, and offsite prefabrication. The next topic is specific requirements for the planning and layout of prefabrication plant. What is prefabrication plant? Where the concrete components or the concrete elements are made is called as a prefabrication plant. The main things while considering the planning for a prefabrication plant is, first one is type of element to be produced, and the second one is what is the output of manufacturing, and the third one is location. These are the main three factors. The selection of type of plant is based on the type of element to be produced and the location. Location part is mainly based on the availability of materials, transport facility, availability of labor, availability of power and water sources. Type of production process. There are two production processes, stationary mold and movable mold process. Then finalizing the area required. What are the area required for the prefabrication plant? There will be some storing area for raw materials and casting area and stacking area. There are several areas for the prefabrication plant. Then let's move on to the plant layout. What is plant layout? The manufacturing cost of the prefabrication element is mainly depend on the plant equipment and machinery placed within the site. Plant layout first depends on the manufacturing cost. By reducing the unwanted materials and unwanted manpower, the manufacturing cost is much more reduced. Process requirements. The process requirement involves the machinery and equipment should be planned to place in the position according to the sequence of operation. There is a several sequence of operation like reinforcement and then framework and then casting and then curing. This is a sequence of operation. The next point in the planning layout is nature of operation. The frequently used machinery should be placed very conveniently. Then maintenance of the equipment. Each and every machinery and equipment should be maintained regularly. Then safety of the workers. High safety measures for the workers should be followed. Then for future expansion. Layout design in a prefabrication plant should be provided convenient working condition for each process and efficient flow of labor and equipment between the various working areas for the further expansion. Adequate space between the machineries. Simple spaces must be provided between the machineries to reduce the congested working atmosphere. Modular coordination. It is nothing but the coordination of dimension. It is the concept of coordination of dimension and space in which the building components are positioned. It is called as a module. One module is equal to 100 mm. It is an international standard value. The main objectives of modular coordination are to facilitate the cooperation between building designers, manufacturers, distributors, and to optimize the number of standard size of building components, to simplify the site operation and to ensure the dimensional coordination between the components. There are two types of model. One is basic model and another one is multi-model. Basic model is the one we have already seen. 1 m is equal to 100 mm. It is a basic model. Multi-model is the standard selected whole multiples of the basic model. Then modular grid. Modular grid is a rectangular coordinate reference system, which is the distance between the two consecutive lines is a basic model or the multi-model. There are several types of modular grid. And next topic is standardization. Standardization is nothing but the process of making uniformly interchangeable components. The main advantages of standardization is easier in design, easier in manufacture, easier in erection process. Factors influencing the standardization. The main purpose of standardization is to limit the number of types of elements and number of size of elements. To use the large size of elements so as to reduce the number of joints, and to limit the size so as to manage the overall weight to handle the component during its stacking, transportation and erection. Prefabrication system. There are four main systems. First one is large panel system, structural frame system, lift panel system and mixed system. Large panel system consists of longitudinal wall system, cross wall system and combined wall system. There are three main protection systems, which are stand system, conveyor belt system, and aggregate system. In stand system, the sequence of protection does not move automatically. In conveyor belt system, in the sequence of protection moves automatically to the next stages like reinforcement, framework, then casting and curing, like that. The third one is the aggregate system. Aggregate system is used for the very large components. These are the main process of prefabrication, manufacturing process on the production site, stacking the components before shipping, transportation, and erection on the construction site. It is the manufacturing process. This chart shows the manufacturing of prefabricated components. At first, the raw materials are collected. Then the raw materials are transferred for the concrete mixing with the addition of water. The rebars are cut, bent, and fixed to the casting bed. Then the concrete mixture is transferred to the casting bed, and then the concrete is poured, and then the batches move on to the curing of concrete, and then demolding of formwork. Now the components are ready for transportation. These are some of the machineries used for the handling of prefabricated components. This picture represents the stacking of components during transport and also the storing of components. It is the stacking of components. This figure shows the correct method of stacking or storing of components. It is the horizontal stacking. It is the wrong method of stacking. There is more than 2 supports for the horizontal component. It's also wrong stacking method. There is a ununiform support for the horizontal stacking. Wall panels should be stored vertically like a rack system. These are the different storage and stacking examples: stacking of wall panels and the stacking of beam and columns. These are the images showing the different types of elements of stacking: precast hollow slab, parapet wall, precast planks. These are the different stacking methods. Transportation. These are the precautions during transport. Polythene wrapping should be used, and also the timber packer should be used to secure the precast elements. Erection. Erection is the process of installation of components on the site. It is the lifting point for the precast beam element. It should be located at about 1/5 of the beam length measured from the edge. It is the lifting point for the precast wall element. It is the lifting of precast slab element. Whenever necessary, multiple lifting points can be designed and located to minimize the stresses within the slab element. It is the lifting process of precast column elements. Columns are usually first handled in a horizontal position. Slings are attached to insert at the top to facilitate the rotation of the elements to vertical position before hoisting and placing to their designed location. There are several machineries used for hoisting. There are several cranes are used, which are climbing cranes, portal cranes, tower cranes, and mobile cranes. I hope you all understand the session. In next video, we will move on to the further topics. Thank you all.